Right, so the very last reaction that we're going to look at for our benzene is the acylation reaction. Okay, and again, so acylation and alkylation are both part of Friedel-Crafts, so they were invented by these two guys over here, so it's sometimes called the Friedel-Crafts acylation. Okay, now let's look at the overall reaction. So again, start off with our benzene ring. I'm just going to draw that hydrogen in the top over there. What we do is we now react it with something with a C-double-O bond, okay? Because the aim is to add that functional group onto our benzene ring. In this case, I'm just going to put a CH3 over here, okay? So what we want to do is we want to add this kind of ketone part over here, okay? Now, in order to do this over here, we need to have directly attached to the C-double-O, we need to have a chlorine. Now, we've never seen this functional group before, okay? So I'm just going to cover that quickly. So this functional group over here is called an acyl chloride. Okay, so essentially it's just like a carboxylic acid, but instead of an OH, we have a chlorine attached over here. Okay, so the aim is to add this chain onto my benzene ring, which is why I'm using this acyl chloride over here. And again, this is going to be a substitution reaction, so electrophilic substitution. So I'm going to have this group being substituting this hydrogen over here. Okay, so C-double-O and my CH3 there. Okay, so that chlorine and that hydrogen there are going to form my HCl at the end over there. So again, two reactants and two products. I've now added this ketone functional group to my benzene ring. Okay, again, you need to have a halogen carrier in this one because it's always going to be chlorine over here. We always use either AlCl3 or FeCl3. And again, this can be done at room temperature and pressure. Okay, right, so let's move on to the mechanism. So again, 3 steps. Step 1, you guys should be getting in the habit of this. So step 1 is always the generation of the electrophile. So we have our compound, our acyl chloride here. Okay, we then react that with our halogen carrier, which I used as AlCl3. So what the AlCl3 is going to do is going to pluck off a chloride ion over here, and that's going to leave behind this weird looking thing over here. Okay, so it's a carbocation, positive charge on that carbon. This over here is going to be our electrophile, and the other product is AlCl4 minus. Okay, so again, positively charged. This is going to be our electrophile in this case. Okay, so moving on to step 2. This is where we do the substitution reaction using our curly arrows. So starting off with our benzene ring, draw my electrophile in. So I'm just going to flip it the other way, like that. Okay. Curly arrow starting from our delocalized ring, going to that carbon delta positive. That's going to form a bond with that. But in that process, it's going to disrupt that delocalized system in the middle. So again, our horseshoe with a positive charge in there because we've lost 2 electrons from that delocalized ring, form a bond between that carbon and that carbon there. Want to reform that delocalized ring. So electrons from this bond over here go back in there, and that produces, I'm going to try and fit into the board over here, my ketone there, and it also releases a H+. Okay, So that H plus is now going to be used in step 3. And step 3, as we've seen before, is the catalyst regeneration. Okay, right, so we have H plus in step 1, we made AlCl4 minus. So now we want to regenerate our catalyst, which was AlCl3, and we want to form our other product, which was HCl. Okay, so overall, regenerated our catalyst, made the other product, and we made that ketone in step 2 as well. Okay.